All right, we'll get started. Ember ATX. Do you guys like code? Do you guys, because when they asked me to give this talk, they were like, these guys really, really like code. Like a lot of code. Like you gotta show, like there's gotta be slide after slide out of code. So guys, do you guys like code? Yeah! All right, let's go. I love code too. I love it. I think about it. I dream about it. All the time, I'm thinking, what could I be coding right now? I wish that I could code all the time. I wish any time that was any time would be coding time. But that's not how it is. I don't code all the time. I actually spend a lot of time writing about code and talking about code and not actually writing it. But that's kind of how it is. It's how it's got to be. You know, if you want to write code that's fit to purpose, you got to think about it and you got to talk about it. And sometimes glossing over all those details is the right thing to do when you got to get a message across. But it doesn't mean that those details aren't they're still there to unpack. So I was at EmberConf about 2 months ago, and I gave a talk on immutability where I spent a lot of time talking about, you know, my personal problems, all the things that were going wrong with the code that I was writing, and I talked about immutability as this kind of high-level thought tool for dealing with those problems. But I really kind of glossed over, didn't really touch on any concrete solutions. I didn't really talk about the code. I only really touched on it, which is a shame because I made some pretty crazy assertions in that talk. And I said them because I wanted you to provide this minimum set of very concrete steps that you could take to get started with coding in an immutable style. But what I was kind of forced to leave out was this roadmap of what the terrain looked like ahead should you choose to embark on that journey. But that's a really, really important roadmap not to have. If that's where you're going with your application, because the impact of those details, for better or for worse, those are the things that you're going to live with in your day-to-day, every day. And so that's actually why I was actually really thrilled that I got invited to give this talk, which is more of a continuation of the story. So I get to share some of the details around immutable thinking. Because when your UI becomes like unresponsive, or you're up late at night and you're tracking down some weird risk condition, it's not the thought tool, it's not the philosophy of immutability that's causing those mysterious exceptions to appear in the console. It's the details. And so that's what I want to get into today, the details like code. And so in that talk at EmberConf, I was mostly answering the question why. Why should I care about immutability? What problems does it solve for me? What pain is it going to address? And that is a really, really important question, why? But we're not going to talk about why today. Today's not about why. Today's going to be more tactical. We're going to talk about how. How do we put these ideas actually into action? We will cover a basic architectural review of the ideas, but then we'll see how we can actually take those ideas to map out a way forward to build, as an example, a component to upload a file. So to review, with an immutable style, the key shift in thinking is that you want to achieve this mental separation of your application into player and content. Player and content. You're going to hear me say that a lot. And it's very important, but we always want to be asking ourselves, first, what is the content of the experience that we want to be providing to our users? And I always focus on the content first. It's only once I kind of have the model of the content in my mind that I start thinking about how am I going to play this back to the users. Because it is that content, it is that model that drives the rendering process, no matter what framework you're using. And once you have that content, it is yours. You can keep it. And just like any other, you can keep it just like any other content, be it video content or audio content, you name it. And like a video track or an audio track, the content in a user interface that's written in the immutable style is just a stream of states. Okay? You can just think of it as a stream of states, just like a movie. And so, at least in Emberland, we're used to thinking of the model as a single object. Okay? And we need to move away from that. Our model is not a single object. Maybe we think about it as the properties of our component or an Ember data record, but we need to move away from that. Instead, we want to think about our model or our content as a set of discrete frames. So here I have a set of discrete frames up there, and you can see each one, it's got well-defined boundaries, it's got a start, it's got a finish. Each frame of content up there exists completely and totally independent from every other frame of content. I can pick one off and I've got it, and it's mine. But when we take that static content and we render it in succession with a player, well then that's when we actually perceive the experience. So this is a movie from 1917 that's a favorite of mine. It's called The Cure. But this is a different kind of movie that I want to show you and we're going to conceive of. We're going to think about how can we look at a file upload component as a movie. How can we look about the experience of uploading a file as nothing but a stream of static content that's being played in succession? So I actually wrote a very, very simple stripped down version of a file upload component for this talk. And so here's a movie of it in action. You can see I'm going to upload some puppies because everybody loves puppies. There's puppies cuddling with each other, and we get progress, and then it says the file is uploaded. And so that's our desired outcome. That's the experience that we want to give to our user for uploading a file from the browser. That's the movie that we want to make. So how are we going to break this down? How are we going to break this movie into individual frames? Well, we can do that just by imagining, whether you're watching a cartoon or whether you're watching a movie, you can imagine how the content breaks down if you were to just freeze it for a moment in time. And so here I've got 4, I think, illustrative states up here that serve as like what we would expect if we were to freeze the content at any given time. And they answer, the reason I've got broken it down in here this way is because they answer, I think, the salient questions for the file upload. 1, has the upload started yet? 2, has the upload finished? Like, have we gotten to our destination? And 3, what is the thing that we're uploading? And how much progress have we made towards making that upload? And you can see those questions right here. In this state, we're not uploaded, or we're not started. Here we're started, but we've got no progress, but we've got, we very clearly have the entity we're uploading. Here we have partial progress, and there we've got that little check mark that lets us know that we're at the end of the process. So now that we have our individual frames, we know what these individual frames look like. Our next question that we have to ask ourselves is, what is the state that drives each one of these individual frames? How can we put in the simplest amount of data, that the data that we need to draw those pictures up there? So let's have a look at that first frame. All we can see there is the upload button. There's nothing else. No file is selected. There's certainly no progress indicated. It's pretty much empty. There's nothing up there, but nothing is, in fact, something. So what is the something in terms of those questions that we were trying to ask ourselves earlier? Is it started? No. Is it ended? No. What is the file associated with this upload? There is no file. We have not selected it. and there certainly is no progress. Okay, so if we're measuring our progress on a scale of 0 to 1, it's pegged firmly over at the 0. So it's really, really easy to capture that. Right, there we have, this is kind of the data that's corresponding to that frame of content. But then something happens, right? Something wonderful. Our user presses a button and selects a file. We have an event. And we need to render now the fact that the file upload has begun. And we know what that looks like, right? That looks like here. We've got the name of the file. We've got a preview of it. And even though we don't have any progress yet, we still have this slot allocated to give an indication to the user that that's where the progress is going to go. So let's check it out. What is the content, or what is the data that we need to render this frame? Well, it's going to look a lot like the previous frame. It's going to answer those same 4 questions, but there are, of course, notable exceptions. Is it started? Yes. Is it ended? No. But now we actually have a native JavaScript file object associated with this, although the progress is still 0. So let's look where we are now. First, we were at rest. Then the user selected a file, and we transitioned to uploading. So what happens next? Well, bytes are going to start streaming to the cloud. Okay, and we need to reflect that. We receive another event, not from the user this time, but actually from the native browser API. We're going to get a callback from that network request. And it's going to tell us on that event that there's been progress. More bytes have been transferred, and that we're getting closer to our goal. And so that's going to look something like this. It's almost exactly like the same state. It's got the same questions. Is it started? Yes. Is it ended? No. The file is exactly the same, but here we have a key difference. We've got progress. Okay? And that's going to look like this. We were at rest. Then the user selected a file. We transition to uploading. We get progress. And then what happens over there? Well, we are really close. We are really close. We actually get the final event. It arrives. It lets us know that our upload is successful and that this is going to give rise to our very, very final state. Okay, and that's going to look like this. Again, very similar to the other one. It started, yes. It's ended, yes. And we have the file, and the progress is right over there at the other end of the spectrum from where we started at 100%, as far as it's ever going to go. Which, this is all to say that we made it. We were at rest. The user selected a file. We got progress. We ended up in the success state. So at the end of this process, we've got some pretty sweet boxes and lines and arrows up there. And I want to take a little moment to reflect and relax, because you might be thinking, hey, Charles, progress, file selection, add, wait, where did you create the XML HTTP request up there? Who's building these objects you're talking about? We didn't register any callbacks. We never put any action handlers in a template. And you promised me code. Like, where's the code? You guys like code, right? Yeah. Yes! You are going to love slide 50. The point I want to emphasize is that these discrete frames, these are what embody our content. Oops. Let's see.
It's telling you to show the code.
So these are the frames of our content, not how and when to transition between those frames. We will write code to do that, I promise. But I want to focus on the content first. Okay. Let's have a look at this again. Because once we do know our content, we are really close to being able to write the code in a very rote and mechanical process. Because I'll give you a hint up there. every one of these little frames in our storyboard, that's going to be its own JavaScript object. Every single one of them, there's going to be a one-to-one correspondence. It's going to be self-contained, and it's going to be immutable. And the reason that I use the word state, it's not a coincidence, because each of these objects is a state, and what we've really designed here is a state transition diagram. This is the whole process. And what we've really built is a state machine, and what we've really described is a state machine. And once we have a state machine describing our workflow, well then we can use a really, really, really simple, elegant, and new framework to turn this into code. This is something that I'm going to be introducing to you today. I'd like to introduce to you JavaScript. That's right. We're going to just use plain JavaScript, nothing fancy, nothing special to describe that state machine up there. Because we're going to use an object or a class to describe each state, and then we're going to use a method to describe each state transition. So let's start at the beginning. This is our very first state. Remember that state? It's a special state. It's our start state. It's empty. It's got a lot of implicit properties, and it doesn't contain much information. Actually, it contains a lot of information, but not externally defined information. So what does this JavaScript object look like? You guys ready for the code?
Yes.
You guys ready for the code? All right, here we go. It's not a joke this time. It's actually the code. There you go. That's pretty breathtaking, isn't it? That's revolutionary and radical. And if there's any other superlative adjectives, we can innovative. We can heap those on there. And we'll see. You might be thinking, why shouldn't I just use like a little simple object? Why model this as a class? And we will get to this. But those properties right there that we're setting in the constructor, those correspond to the properties that we had in our start state. Do you remember those? Right there. There they are. Not started, not ended, no file, no progress, faithfully recorded in JavaScript. And so it's really, really, really easy. We can use those in our templates just straight away. But there's something that's missing in here in the description of this state. Because a state in a state machine isn't just its properties. When you describe a state, you have to describe the ways in which that state can move to another state. And the way that we're going to do that, so in this case, we have our start state, and we have a transition that happens on file selection to the uploading state. And the way that we're going to do that is with a method. So we take that transition, and in this case, this is the transition when we receive a file, and we generate a brand new, fresh state from it. And in this case, it's going to return a new instance of our uploading state, which, of course, we have not written yet, but we will. Now, there's something to recognize in this transition method. Take a good look at it right there, because it is immutable in the true sense of the word. Once you construct a state, you never, ever, ever, ever set any of its properties ever again. And the only way that you can incorporate new information into this data structure is by capturing it with a state transition, which, of course, corresponds to a method. So in this case, because the destination of our state transition is the uploading state, our select file method is going to return an instance of that. So let's look at that one more time. We're transitioning from start to uploading. And so because the source is start, that's where the method is. And the target is uploading, so that's the instance that we're going to return. So let's actually talk about that uploading state right now. And you'll notice that unlike the start state, the uploading state takes this file in its constructor. So you can see it's reflected in the class definition for this uploading state. And you can create this uploading state. You cannot create it without a file. Okay? You can't create it without progress, incidentally, even though there's 0 is the default. And that's because that is implicit in the constructor. It's impossible to create an invalid uploading state. And that's reflective of what we decided back at the beginning. You need to have a file, and you need to have progress with your uploading state. So again, that was just the properties of the uploading state, but let's look at the transitions, because a state is also its transitions. Now, unlike the start state, there are actually 2 transitions out of the uploading state. One transitions to success, but the other transitions back to the uploading state. But that just means that we need 2 transition methods. And so just like we did with the other transitions, we're going to use new information. We're going to capture that for the next state by putting it in these state transitions. So if you'll notice, when we're actually in the success, like when we call loaded, we're actually not including any new information other than the fact that we are transitioning to the success state, but we do carry along the file over to the success state. And so that's it. That's the basic idea for taking these states and mapping them into JavaScript classes. You've got code that captures the properties and the valid transitions for your content. And because these states are immutable and they are only generated through state transition methods, you've got very, very strong guarantees about their validity. That content is now, you know it's going to be in a good state, and you can keep it. And so there's some really, really interesting things about this. This code that we just used, this represents a state machine that you can put in any JavaScript runtime. And notice I didn't say an Ember runtime. I didn't say a React runtime. I said any JavaScript runtime. You could take this and you could put it in, you could use this for an upload component in like a Node.js console. Obviously, you'd have to write the rendering portion to render to the TTY, but you could. It's theoretically possible. We're kind of spoiled in the HTML world because like all of our frameworks take care of the rendering for us. But that's the thing. This is just content. It's just content. And this content is really, it's super powerful. It is the heart and the foundation of your application. And I believe it is what you should spend the most time on. But by the same token, without a player, it is completely worthless and useless. Because the content is so pure and so immutable, you can't actually do anything. It just is a pure representation of state and how state is generated. So yeah, you need side effects if you want to provide that experience. And that's kind of where the rubber hits the road. It has to happen somewhere. And so you have to have something that keeps track of what is my current state, right? What is the thing that maps platform events to state transitions? And finally, something needs, when you have a current state, needs to actually render it to whatever medium you happen to be rendering. And that thing is the player. So remember we talked about the content and the player. We've just been talking about the content, so now we're going to talk a little bit about the player. And so today, we're going to show how I generated the Ember component that we saw. And we're going to use a simple Ember component as our player because it really captures all 3 of those responsibilities. You can use the state of the component as kind of a state container to say what is the current state. And of course, you can use, it's got, with the actions, it's got a nice mechanism for event mapping. And of course, with components, you get rendering for free because it's an Ember component. But I do want to emphasize that this is a little bit tricky on how you should go about writing the player portion, because there's these kind of 3 responsibilities. Sometimes your state lives up in the route, sometimes it's in the component. And the best practice around this is not really settled in Ember. So the example that I'm about to give, I do not want you to take as gospel, but merely as an example of a way that you can, of a technique that you can use to get started and achieve success in a very short time. So here we go. Let's have a look at the component the actual component that I wrote for this. And so let's look. We talked about the player having the responsibility of state management and event mapping and rendering. So let's take a look at the event mapping first. You can see that we're going to want to have an action that when the file is chosen, we're going to do something right there. We're going to do the state transition. And then when we get progress events from our XHR, we're going to want to do a state transition here. And when we get an onload event, we're going to want to get a state transition there. And that really makes sense when you think about it as the state management of the component, because what's happening there is on these events, we're taking the model, we're invoking the state transition method on it, and then we're replacing the entire model, okay? And so we set the model to the model returned by the state transition. And we do that there when we first select the file, whenever we get a progress event, and when we finally get the success event from the browser. And that's it. It really is that simple. And we can talk more about that after the talk, because a lot of these things really are kind of up in the air. So for example, a lot of people use Ember Redux to take this state management part out of the component. But this technique, it turns out, works really, really well inside of a Redux reducer. It makes the actions map very, very cleanly to state transitions. So that's an interesting possibility, and there's just a lot of exploration that's going on around the best way to manage state. But the thing that I can recommend without hesitation and unequivocally is that you focus on your content. Because no matter how kind of the future of state management and playing the content shakes out, you will be able to take that immutable content with you wherever you go, in whatever construct you choose. Whether that's an Ember component today, whether it's a Redux store tomorrow, or maybe in 2 years' time it will be like an RX observable, a generated stream of states. So remember, the first step is envision the human experience for your component or for your app. You need to think about it just like a movie. Then, once you've got that, you want to break it down into those demonstrative component frames that really, really partition the states and capture the information that you need to represent. Then, once you've got that, you want to break that down into a storyboard that contains the data at each step that's going to be taken to render those frames. And what events are going to happen that are going to relate those frames to each other. And then, once you've got that, you can break it down into a state machine. And then, when you've got your state machine, you can just, almost like grinding the sausage, you can break that down into ES6 classes that have the properties and state transitions represented just as simple JavaScript. Because once you own that content, once you've got that state machine, once you've got it on your disk and in your pocket, you have essentially distilled the truth of your application. And knowing that truth is going to be your friend in any situation. Thank you. So I can take questions. Man in the hat.
I'm just a simple country programmer. But what are the memory implications of generating all these objects?
So that's actually a really excellent question. So the question is, you're generating objects for each individual state. So what are the memory implications of that? So let me answer that with some anecdata. So the answer is you do have to be careful about how you construct these objects and what data they hold on to from state transition to state transition. So for example, if you have a subsequent state having a reference to the prior state, then you're essentially constructing, among other things, a gigantic linked list, which can chew through your memory. But if you're like the objects that we wrote today, they copied what data they needed over, but they didn't actually carry anything more than that. And so at any given time, there was only one object that was needed. And so your JavaScript runtime is actually very, very good, it turns out, in recycling simple POJOs, because that's the thing. These are very simple JavaScript objects that are, they're prototype-based objects, and that's exactly what your browser is really, really, really good at. And so when you contrast that with how much does it take to actually instantiate an Ember object, I mean, God, there must be hundreds of objects just to call create. Much less actually call a method, all the events and observers and everything that gets fired off. How many stacks are there? How many objects that are created? I don't have any hard data, but this process is actually more lightweight.
Like one of the major issues that I have whenever I'm dealing with Ember applications is debugging. Like console.log Ember object is just brutal. How does this? Do you have to log like Ember objects? Obviously not. Like so when you're doing the component, like.
So the question is how does this work in terms of debugging and being able to visualize? And again, this is these JavaScript objects, because they're just simple JavaScript objects. When you log them to the console, your browser is hyper optimized for this use case of logging JavaScript objects to the console. So you get a very succinct summary of the constructor that was used and all the properties that it has. If you're for things like Ember objects, you can't actually click and drill down into computed properties. So when you're logging an Ember object to the console, if it's not, you need to kind of get the reference to the object and then call a bunch of methods. And of course, some of that is ameliorated by having the Ember inspector, but that's kind of, the Ember inspector is this translation layer. It's a great translation layer, but sometimes when you're kind of off-piste, you want to be able to just log something out to the console. The other thing where this really, really helps in debugging is if you have a stream of states, like you do, if you're using a single model or you're using the component properties, let's say you have 10 state transitions, if you're using a single Ember object as your model, you can log out 10 times, but because it's all one object, every single log statement is going to, when you start drilling into it and inspecting it, is going to have exactly the same properties. And so it can be very difficult to tell when this kind of bad thing happened or what was going on at that log statement. But if you're using these immutable state objects, you log it out to the console and it never changes, and the only way that change is reflected inside the application is by generating a new one of these objects. So it's actually, Rob and I were actually debugging something earlier today, and it was nice. You could just see, it's in this state, it's in this state. Oh, now it's in this state, this state, this state, this state, and now it's in this state. And so you get a very, very clear idea of what exactly happened when and why.
I saw in your code example that you were blowing away the model with a new state. For those of us who rely heavily on the Ember inspector for debugging, how does that work with the Ember inspector if you are blowing away your model that you got from your route?
So the question is if you're blowing away your model inside your component, how does that work with the Ember inspector? So the answer is the Ember inspector gives you a live picture of what your Ember application looks like at any given point, so you can drill down into a controller, a template, a route, and you can see what all of its properties are at that moment. And so inside the Ember inspector, you will see a model property that represents what it is in that moment. And that's all you will get because you are blowing it away. But by the same token, if you're not using an immutable technique, what you will see in the Ember inspector is whatever those properties happen to be in that moment, because if you're not using immutable data, you are blowing away the state every single time you set a property. So the answer is, from Ember From the Ember Inspector perspective, it's about the same. But you know, a companion point to that is at some point, you do need to have mutable state that you're updating and blowing away in any system.
Have you used this technique with Ember data and like Ember data models? How would that even work?
So the question is, have we used this technique with Ember data models? The answer is yes, but what you do is you essentially copy the properties of the Ember data model into an immutable object. You make, you know, you have state transitions through whatever way you want to change that Ember data object, and then when it's time to commit those changes, you have some action that takes the last realized immutable state and then applies those changes to the Ember data object and saves it.
Like a proxy object?
Not a proxy object. I mean, yes, but no.
Is there a repo that shows the example of how you do that?
I don't think that we have any repos using specifically cloning Ember data. You also had your hand up.
I did, but I can ask you later. It wasn't good enough to ask.
Yeah, that's true. Anybody else? All right.